Hello everybody. We are 3 weeks away from the end of the semester, and I'm assuming that brings you some pretty great joy. I know I'm kind of ready for this one to be over even more than normal, no offense, but this online stuff is interesting. But we're doing it again this summer. There's just going to be a different format, and we'll have more time to plan, which will be really nice too. So we are in section 7A. We're going to talk about the fundamentals of probability. So if you go ahead and look at the worksheet, I'll read through number 1. A local ski sale features 9 different types of skis, 8 different types of bindings, and 12 types of boots. Okay, with all of those things, how many different ski, binding, boot packages are available? So if you're a skier, you know you need skis and boots and bindings to be able to go. So say you want to buy them all at once. How many different ways can you do that? Assuming that you are buying one from each category. I'm going to show you a really easy way to calculate it. How many different types of skis are there? 9. And then we said there are bindings. We said 8, and boots we said 12. So to figure out how many different ways let me rephrase. To figure out how many different combinations you can get with all of these, that's all you do is multiply. So 9 times 8 times 12 gives you 864. So there are 864 ways, and you might be surprised by that, but maybe you're not, to pick something here, from here, from here, from here. You'll get 864 different options. That's all you do is multiply. Okay? So let's look at number 2 then. Go ahead and read through number 2 while I erase. Number 2 says, 3 districts each elect 1 representative for the county commission. There are 2 candidates in District 1, 3 candidates in District 2, and 4 candidates in District 3. Okay, those are the different districts. There are 2 candidates in District 1, 3 candidates in District 2, and 4. So they're asking how many different commissions are possible. So that means you need to choose someone from District 1. You also need to choose someone from District 2, and you also have to pick someone from District 3. What's the answer? It's 24. Very good, and you found that, hopefully, just by multiplying. 2 times 3 is 6, times 4 is 24. Good. All right, let's do number 3. It's kind of like what we were doing. We're going to do it out, though. Suppose the Red Sox play, this is number 3, suppose the Red Sox play a doubleheader when sports season starts again. Using W for win and L for loss, they want you to make an actual list of all possible outcomes for the doubleheader. Doubleheader means 2 games, right? 2 games in a row. If we are only interested in the total number of games the Red Sox win, what are the possible events for the 2 games? So let's make a list of all the possible outcomes, okay? So we'll say game number 1 and game number 2. Well, they could win them both. Okay, they could win one and then lose the other, or they could lose one and then win the other, or it could just be a tough day and they could lose both. So there are 4 different possible outcomes, right? Win, 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 lose, lose, win, or lose them both. If they're only interested in the total number of games the Red Sox win, what are the possible events for the 2 games? I think what they mean by that is, okay, if we're only talking about wins, W-I-N-S, we could have 2, 1, or 0, right? This would actually also be 1. But the number of possible wins, we could have either 2, 1, or 0, right? There's no way to have 3 or anything like that. Good. That was number 3. We're cruising. Let's keep going. Go ahead and read through number 4, and we'll talk about what it means. using the theoretical method to determine the probability of the following outcomes, use the theoretical method to determine the probability of the following outcomes and events. State any assumptions you make. Okay, so what they mean by this is that in theory, in theory, we're assuming that every single thing has an equal chance of happening. For example, in the first bullet point, we're talking about rolling a single die. If you have a dice, or if you have a die, right, or a pair of dice, you know they have numbers 1, 2, 3, 4, 5, and 6 on them. So what we have to assume here is that in theory, there's an equal chance of getting a 1, a 2, a 3, right? It's all equal. So we're assuming these are all fair objects or cards or dice or whatever that we're using, and we're assuming there's an equal chance of any of them happening. So that's what they mean by theoretical. So for the first one, we're talking about, in this, we want to talk about, okay, the total, in this first one, we're talking about rolling a single die and getting an odd number. So the total number of ways of getting an odd number divided by the total number of possible outcomes. And I'm, of course, going to explain that. This is what we're doing when we're talking about theoretical probability. So in the first bullet point, how many different ways could we roll an odd number? 3, right? We could roll a 1, we could roll a 3, or we could roll a 5. So there are 3 total ways of getting an odd number. Okay, and how many total outcomes are there if you roll 1 die? There are 6, right? There are 6 sides. So then our theoretical probability is 3 out of 6, or since it looks just like a fraction, follows the same rules as a fraction, it's 1 out of 2. So the answer for the first one is 1 out of 2. And that makes sense, right? Because if you think about a die, half of the numbers on it are even and half of the numbers are odd. Okay, what about the next one? The next bullet point. Drawing a black card, a club or a spade from a standard deck of cards. Well, one thing you might want to know is how many cards are there in a standard deck? There are 52. And how many of them are black? Half are red and half are black, right? So you might know right off the bat, it's just 1/2, right? Half are red and half are black. And that would be the correct answer. If you weren't sure and you had a standard deck of cards, you could also count them all out. And you would see that there are 26 black cards. So your probability for that one is also 1/2. They don't always equal 1/2. It just worked out that these two did. I'm going to erase the board. Go ahead and look at the next bullet point. Talking about kids, randomly selecting a 3-child family with exactly 2 girls. I gotta think about this one for a second. Randomly selecting a 3-child family. Oh yeah, so we have to figure out, okay, well, what are the options, right? This is why one threw me off. I remember why. So what are the options? If you have 3 kids in your family, make a list of all the options. You could have 3 boys and no girls. You could have 2 boys and 1 girl. You could have 1 boy and 2 girls, or you could have no boys and 3 girls. Right, those are all possible. And it doesn't matter which order they fall in. It doesn't matter if it's boy, like in this case, it doesn't matter if it's boy, girl, boy, or boy, boy, girl. It's still the same, 2 boys and 1 girl. So the order doesn't matter. We're just talking about the total number of them. So they want to know randomly selecting a 3-child family with exactly 2 girls. Well, you have 4 total options, but only one of them has exactly 2 girls. So the answer for that one is 1 out of 4. All right, let's look at the next one. A randomly selected person has a birthday in June, July, or August. There are actually a couple answers on this one. Since they give you the months, I would say it's perfectly acceptable to say, okay, well, there are 12 total months in a year. And we're thinking about only those 3 months. So we would get 1 out of 4. You may have also done it out a little more specific, and you may have said, well, June has 30 days, July has 31, and August also has 31. And that would give you 92 out of 365. Either one of those answers is fine with me. But this is the more common answer. Since they give you months, just keep it in months and reduce 3 over 12 to 1 over 4. Okay, good. And what about the last one? A randomly selected person was born on a Wednesday. What does that answer have to be? 1 out of 7, right? Wednesday is 1 day out of 7, total days 1 out of 7. Good, let me just check on my time. Good, okay. Let's look at number 5. Halfway through the season, a basketball player has hit 36 free throws. I forgot an R. THROW out of 52 attempts. Oh, 50. Sorry, I'm back in thinking about cards again. Out of 50 attempts. Then they say, based on her performance to date, what is the relative frequency? Here we go, going back to that last chapter. What is the relative frequency that her next free throw will be successful? How could you figure that out? 36 out of 50, if you wrote it as a decimal, right, is 0.72, which is the same thing as 72%. Good. All right, read through number 6 while I erase the board and think about number 6. Number 6, you toss 2 coins 100 times. You get 0 heads 23 times, 1 head 51 times, and 2 heads 26 times. Do you think the coins are unfair? Or do you think they're fair? And explain. What do you think about this one? Are they fair or unfair? People have said, well, why did you only get 1 head 51 times? That's so many more times, right, than 0 heads or 2 heads. But what is true? Sometimes it's tails then heads, and sometimes it's heads then tails, and both of those would count in that middle category. Right, this is kind of like the boy-girl option, or the Red Sox winning and losing, or losing and winning. Right, so the answer for number 6 would be no, they're not unfair. It makes sense that we would get 1 head about twice as many times, because sometimes it's heads tails and sometimes it's tails heads. Does that make sense? If you're not sure, write it all out. I'll show you. 0 heads 23 times, so that means tail tail. Right, then we could also get head tail, tail head, or we could get head head. In theory, what should each one of these be? What percentage of the time, or what fraction of the time should we get each one of these situations? About a quarter, right? Or 25%. So in theory, if we have 100 throws, this should be 25, this should be 25, this is 25, and the same thing here. But this is 0 heads, it should be about 25. This is 2 heads, which should be about 25, which it is. But these two we would have to add together to get about 50. Because both situations are considered just 1 head. Hopefully that makes a little more sense now that you can really see it out. Okay, let's talk about number 7. So when we're talking about probability, right, the probability of something happening plus the probability that something doesn't happen equals 1. So I'm going to write it out in fun stats. The probability of an event, that's what we call it. E means an event. Plus the probability, how do they write it? P naught, I think? The probability that the event doesn't happen equals 1. It's kind of like saying it's 100%, right? 100% of the time something either happens or it doesn't happen, right? So the probability that something happens plus the probability that it doesn't happen will equal 1, or equal 100% if you'd like to think about it that way. So in number 7, what is the probability of not having a result of 3 tails when flipping 3 coins? sometimes it's easier to find what the probability is and just subtract it from 1 to get this, right? So I could rewrite this, write that part down. I could say 1 minus the this is the number 1, minus the probability that something happens equals the probability that something doesn't happen, right? Because it either happens or it doesn't. It can't be half and half. We can't roll a 6, kind of. We either roll a 6 or we don't, if we were talking about that. So let's look at number 7 again. What is the probability of not having a result of 3 tails when flipping 3 coins? I don't know. So let's think about what the probability is of having a result of 3 tails when flipping 3 coins. If we have 3 different coins, this is each a coin space. Coin. How many options do I have for the first coin? 2, right? I can either flip heads or tails. And what about the second coin? It's the same and it's the same. So how many different outcomes could I have here? I could have 8 total outcomes, right? I could have 8 total outcomes. And what's the only way I can flip 3 tails? They would all have to be tails, right? So there's only one way. So this right here represents the probability that I get 3 tails. But the question is asking, what is the probability that I do not get 3 tails? So I have to say 1 or 100%, stick with 1, it'll be easier in my math lab. 1 minus this, and that's the correct way to do it too. 1 minus this equals the probability that it's not going to happen. So I'm going to say 1 minus 1/8 equals what? And you might know the other part of 1/8 to get to 1 is 7/8. And there's your answer. Or you might have to do your fraction math and convert 1 to 8/8. 8 minus 1 is 7, and you keep the denominator the same. Good. So what about number 8? What is the probability the next person you meet was not born in July? I would find the probability, and they're saying use the days, use 365 days to represent a year. So I would find the probability first that someone was born in July, and then say, subtract that from 1. So the probability that someone was born in July is equal to 31 over 365. So then what's the probability that someone was not born in July? Just subtract it, right? And you'll get what? 334 over 365. Good. If you have questions on these, again, feel free to email me. Let's see, how are we doing on time? All right, let's talk about number 10, I think. Let's do number 10. I don't love number 9. If it comes up in my math lab, though, I'll do a separate video about it. I don't think it does. Let's go to number 10. Compute the probability of rolling 2 dice and getting the same number on both dice. So if I roll 1 die, I have 6 total options, right? And if I want to roll a second die, I also have 6 total options. If I need a 1 here, say we're going to, or actually it's even easier. Say I wanted to roll a 1 here and a 1 here, right? How many ways? Let me think for a minute. Sorry, this one, I know this one, but it's like a weird way to word it. How many ways, how many options do I have here, right? If I roll 1 die, let me label 1 die, I have 6 options, right? 1, 2, 3, 4, 5, 6. And if I roll a second die, I have another 6 options, right? So I could roll a total of 36, or I have a total of 36 options between these two dice. Does that make sense? Hopefully. But how many ways could I roll the same number, right? I would have to roll a 1 and a 1, or a 2 and a 2, or a 3 and a 3, etc. So I can only do that in 6 total ways, right? If I roll a 1 and a 1, a 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, or a 6 and a 6. So out of all my options, all of the ways I could roll these two dice, I can only 6 times roll the same number on both dice. I hope that wording makes more sense now. So since it's 6 over 36, right, we still have to reduce it, and we'll still get 1 over 6. Let me know if that doesn't make sense. I think it does, though. I think I figured it out. All right, what else? Let's do number 11. Compute the probability of randomly selecting a pair of white socks from a drawer that holds 5 pairs of black socks, 9 pairs of blue socks, and 8 pairs of white socks. So how many total options then are in that drawer? Right? How many different ways could I pick socks? Now, what I just did here was bad. That was bad, teacher. I have 5 black socks, 9 blue socks, and 8 white socks. But how many pairs of socks total do I have in the drawer? Right, 22, right? I'm just adding these all together. There we go. To get 22 pairs of socks. Right? Just think about this logically. If you have a drawer with 5 pairs of black, okay. Well, I have 22 different pairs of socks that I could pick out. But I want a pair of white, and there are 8 options. So the answer is 8 over 22, but we still have to reduce it. Go ahead and cut them both in half to get 4 out of 11. Good. Good, good, good. All right, last one, number 12. Compute the probability of waiting longer than 15 minutes when you arrive randomly at a bus stop at which the bus arrives promptly on the hour and half hour. What do you think about this one? This is 30 minutes, right? This is 15 minutes, and this is 0. Okay, so if you arrive at 12, the bus is there, so you're good. But if you arrive at 1, 2, 3, 4, 5, 6, 7, all the way up to 15, 1, 2, 3, 4, all the way up to 15, you'll be waiting more than 15 minutes, right? You'll be waiting 15 minutes or more out of how much total time for that half hour out of 30 minutes. And you could do the same thing for this side of the clock. If you arrive right on the dot at 30, you're good. But at 31, all the way up to 45, you'll be waiting more than 15 minutes. So from here to here is 30 minutes. So what is the probability then that you'd wait longer than 15 minutes? It's just 1 over 2. 15 over 30, right, which reduces to 1 over 2. Good. So that's just kind of a basic intro to probability. I am going to send you an email. Well, you're probably getting it. This is probably in the email about the plan going forward. We're gonna kind of skip through some sections, but I will assign them in the order I want you to do them, and I'll post the videos in the same order too. And we will take the last week of finals week, the last week of classes. It'll be due on that Friday, so we're going to try to squeeze in as much time as possible to do as many sections as we can, but I'll post them all in my math lab. I'll have the dates and all that. Please make sure you're reading through the emails, and please make sure you are making sure you're keeping up with the dates and stuff, because we only have 3 weeks left. Don't let me lose you now. All right, and if you have any questions, always feel free to send me an email, and just send me an email and check in. Hope you guys are doing well. Have a wonderful day, and I'll talk to you later.